All right, today's lesson is on 4.6 natural logarithm function. And we're going to be integrating the logarithmic function. Now, the antiderivative of 1 over x dx is equal to the natural log of the absolute value of x. Because remember, natural logarithm has to be 0 or positive. You can never take the natural logarithm of a negative number. With that said, if we have 1 over u du, that's also natural log of absolute value of u plus c. Okay, example 1, we are taking the antiderivative of 1 over 4x minus 1 dx. Well, right here, I'm going to let u equal the denominator. So I'm going to let u equal 4x minus 1. I need to find out what dx is, so I'm going to go and take the derivative. The derivative of u is du, and the derivative of 4x minus 1 is going to be a 4 dx. I need to solve for dx, so I'm going to divide by 4 to both sides, so du over 4 equals dx. Now let's go ahead and plug this in. So this is going to get plugged into right here, and this is going to get plugged into right here. So this is the antiderivative of 1 over u, and then dx equals du over 4. That 4 is going to be a constant. That 4 is going to go out on the front. So this is 1 over 4 integral of 1 over u du. Antiderivative right here of 1 over u is the natural log of the absolute value of u plus c. So this is going to be a 1/4 natural log absolute value of u plus c. Last step, plug the u back in. So I'm going to put 4x minus 1 right there. So final answer is 1 over 4 natural log absolute value of 4x minus 1 plus c. Example 2, we're going to find the area of the region bounded by the graph of y equals x over x squared plus 1. The x-axis and the line x equals 3. So let's see what this graph looks like. I'm gonna go to my y equals. I want my fraction, so I'm gonna hit alpha y equals, there's my fraction. I'm gonna have x in the numerator and x squared plus 1 in the denominator. Now, when you're graphing it, you're gonna only graph it up to 3. So let's go to my window, and I'm just gonna go from -1 to 4. Okay, so I could probably go lower on my y. Let's go -3 to 3. Let's see if we can get a better picture. There we go. So you're only going from 0 to 3, though. We're going to end it right there. So it's just going to be a little curve going up. So this is what the picture looks like. And we're going to stop at 3. It's this region right here. This is the curve y equals x over x squared plus 1. Because this is bounded by the x-axis, this is going to be a dx type problem. So now I'm going to set up my integral. My integral is going to go from 0 to 3 of the function All right, I need to go ahead and let u equal something. I'm going to let u equal the denominator, okay? Because I want the highest exponent. Always let u equal the highest exponent. So u is going to equal a 2x plus 1. I need to find out what dx is. So then du equals 2x dx. I'm going to divide both sides by 2x. So du over 2x equals dx. So this is going to get plugged in right there. This is going to get plugged in right there. Now, we are doing definite integrals here because I'm giving you the upper and the lower. This is in terms of x. You can go ahead and you can solve it and then just plug those back in, plug the x back in. Let me go ahead and do that first, and then we'll do it with just the u. I prefer just changing them all to u, and that way we don't have to do them back. So right now, if I leave it as a 0 and 3, keep in mind that those are terms of x's. So this is x over, that's going to be x squared plus 1 is going to be the u. Dx is going to be du over 2x, where the x's are going to cancel out. That's going to be 1 over 2. That's going to be a constant. And keep in mind, these are still terms of x's. So this is 1 over u du. Antiderivative of 1 over u is natural log. So this is going to be a 1/2. Oh. 1 over u is natural log. So that's natural log of u from 0 to 3. Now, don't plug in the 3 and the 0 because right now these are terms of x's. So I need to plug it back in. So then this is going to be a 1/2 natural log of x squared plus 1 from 0 to 3. So now this is going to be a 1/2. Now here, this is going to be a natural log. I'm going to plug in the upper bound. That's going to be a 3 squared plus 1. Minus, now I'm going to plug in the 0, natural log of 0 squared plus 1. That's going to be 9 plus 1, which is a 10. So then this is going to be a 1/2 natural log of 10. And then this is going to be 0 squared plus 1. If you know the natural log of 1, that actually equals 0. So I don't even need to put that. Now, let's say I change my upper and my lower. If I change my upper and my lower into u's, I would skip this step and skip all the arithmetic in between. So let's say that I did not change, or I did change it. Let's go back to the very beginning. Now, this is the way I would have solved it. These are in terms of x's. I'm still going to let u equal the x squared plus 1. Now I need to find out what dx is. So right here, I'm going to let du equal 2x dx. So then du over 2x equals dx. So here, it's going to be an x over u, du over 2, x. I'm going to change these. So keep in mind, u equals x squared, so that's going to be a 0 squared plus 1, so that's just going to be a 1 on the bottom. Right here, if I put a 3 square is 9, 9 plus 1 is 10. Now these are terms of u. The x's are going to cancel. That 2 is a constant, it's going to go on the front. So it's going to be a 1/2. And now my integral is going from 1 to 10 of 1 over u du. Antiderivative of 1 over u is natural log, so this is 1/2 natural log of absolute value of u. And because these are in terms of u, I could just straight plug them in. So that would be a natural log of 10 minus natural log of 1. The natural log of 1 is 0, so your final answer is 1/2 natural log of 10. On example 3, I cannot simplify that. I'm going to let u equal the highest exponent. The highest exponent is the x cubed, so I'm going to let it equal all of that. So u is going to equal x cubed plus x. I need to find out what dx is. So the derivative of u is du. And then the derivative of x cubed is going to be a 3x squared plus the derivative of x is going to be a 1 dx, because this is going to have a dx and that's going to be a dx. So I just factored it out. I'm going to divide both sides by 3x squared plus 1. So du over 3x squared plus 1 is equal to dx. My numerator, I'm going to leave it as 3x squared plus 1. My denominator is now going to be the u. And then dx is du over 3x squared plus 1. And now I'm left with the antiderivative 1 over u du. Antiderivative 1 over u is going to be natural log of absolute value of u. And because it is an indefinite integral, I need to have that plus c. And lastly, plug in the u back in. So the final answer is natural log of absolute value x cubed plus x plus c. Right here, I'm going to let u equal what's inside the parentheses. So u is going to be the x plus 1. And now du is equal to dx. So I'm going to have the antiderivative of 2x over u squared times dx is going to be du. Now I have a problem here because I have an x. I need to find out what x is. And actually, this is going to be one of those special cases where if I take this piece right here, u equals x plus 1. If I subtract 1 to both sides, u minus 1 is equal to x. I'm going to plug that into right there. So this is now going to be the integral of 2 u minus 1 over u squared du. I can actually simplify this. This is going to be a 2u minus 2 over u squared du. Because I'm not going to, you can't do quotient rule on integrals. I'm going to separate them. I'm going to put the u squared underneath this one and the u squared underneath this one. So then 2u divided by u squared, that's just going to be a 2 over u. And this is going to be a 2 over u squared. Now I'm going to go ahead and take the antiderivative. Right here, the 2 is a constant. And then the antiderivative of 1 over u, that's actually going to be natural log. So that's going to be a 2 natural log of absolute value of u minus right here, that's the same as saying 2 out in the front, u to the negative 2. So if I add, so 2 is going to be out here. And now if I add 1 to the exponent, negative 2 plus 1 is going to be a negative 1. And whatever the exponent is, I'm going to divide by it. I'm going to clean this up. So this is 2 natural log of u. A negative is going to make that a positive. I have a 2, and then because that's a u to the negative 1 power, that's actually a denominator. And now just plug the u back in. So this is going to be a 2 natural log of x plus 1 plus 2 over x plus 1 plus c. Last problem. Tangent, antiderivative of tangent. Keep in mind, what is tangent equal? Tangent is equal to the sine x over the cosine x. Now, I know this whole assignment's been on natural log. So let's go ahead and let's let the denominator equal the u. Let's find out what dx is. So du equals negative sine x dx. Du over negative sine x equals dx. Keep the numerator, so keep the sine x. Cosine x is going to be the u. Dx is going to be a du over negative sine x. Don't lose that negative. That negative is going to go out in the front. Antiderivative of 1 over u is going to be natural log of u. Don't lose a negative. And then plug the u back in. Now these are going to be the integrals of the 6 basic trigonometric functions. The antiderivative of sine of u du, that is equal to negative cosine of u plus the constant because it's indefinite because I'm not giving you the upper and the lower. The antiderivative of cosine of u is going to be sine of u plus the constant. And the antiderivative of tangent of u, which we just did, is going to equal negative natural log of cosine of x plus c. The antiderivative of cosecant u. Now you can actually calculate that. That's 1 over sine. Let the u equal the sine. But I'm just going to give it to you. On this one, it's going to be a negative natural log cosecant u plus cotangent u plus c. The antiderivative of secant u is going to be the natural log of absolute value of secant u plus tangent u plus c. And then the last one is cotangent. And that is equal to the natural log of sine u plus c. And that concludes our notes.